All right, guys, let's look at lesson 2, which is calculating moles. Converting grams to moles. So we talked about how to calculate the molar mass of something. So now what we're going to use is we're going to use the mole formula from table T. That's on the last page of your reference packet. And we're going to use this. So moles is going to be equal to the given mass over the gram formula mass over the molar mass. And the given mass is always going to be given to you in grams. So the first thing you're going to do is there are 2 steps that you need to follow. So how to convert from grams to moles. You're going to calculate the GFM or the gram formula mass for the compound. Then you're going to plug in the values to the equation and the gram formula mass into the mole calculations formula and solve for the number of moles. So let's look at some examples. So first, how many moles of L are in 39.0 grams of LiF? Here's the formula we're going to use, but since we're talking about LiF as a compound, we need to calculate the molar mass. So we have 1 Li at 6.9, we have 1 F at 19.0, our molar mass is going to be 25.9. This is the calculation that we did in lesson 1, so it should be very familiar to you. Then what you're going to do is you're going to plug it into the formula. So moles is what we're solving for, so that's going to be equal to the given mass, which is what we were given in the problem, over the gram formula mass. Okay? Grams are going to cancel, which is what we want. We have a gram on the top and a gram on the bottom. So then our unit's going to be in moles, and we have 1.51 moles. And this answer is good because it has 1, 2, 3 sig figs in it, and our answer has 3 sig figs, so we are done. Let's look at the next example. Example 2. What is the number of moles in potassium chloride present in 148 grams? So we're going to have to calculate the molar mass of potassium chloride. So we have 1 potassium at 39.1 grams, 1 chlorine at 35.5 grams. So we add those up and we get 74.6 grams per mole. Plug into our equation. 148 is the mass that we were given in the formula over our gram formula mass. Moles cancel. That's what we want. And then we saw we have 1.98 moles. Again, 148 has 3 sig figs. So 1.9 will work. 1.98 will work because it also has 3 sig figs. Let's look at the next. Let's do a practice. So I've shown you 2 examples. Now what I want you to do is to practice this on your own. So determine the number of moles in 8 grams of boron. So I want you to pause the video, try this, and then unpause when you're finished. Great, well, welcome back. So the first thing you should have done is you should have went to the periodic table and grabbed the molar mass of boron. Then you should have plugged into your equation. So mole is going to be equal to 8.0 grams over 10.8 grams per mole. Grams cancel, so we're just going to divide 8.0 divided by 10. We get 0.74. Okay, 0.74 moles. And that is correct. Let's look at practice problem 2. How many moles are in 168 grams of potassium hydroxide? We have to calculate the molar mass. So what I want you to do is pause the video and then unpause it when you're finished. Welcome back. So the first thing you need to do is calculate the amount of grams per mole for potassium hydroxide. So we're going to do that first. We end up with 56.1 grams per mole. Then what we're going to do is we're going to plug into our formula. So when we plug into our formula, we have the mass given in the problem, which is 168, divided by the molar mass of the sample. Grams go away, so we're happy, and we're left with 2.99 moles, and that is our answer. So check your understanding. I want you to try this at home, and we're going to go over it in class. There is a second section to this. It's the opposite. So how to convert from moles to grams. So we're going to use the same mole formula to solve for the grams by setting mole over 1 and crisscross multiply. So we're going to end up crisscrossing and multiplying and dividing, which you're familiar with. So there's a couple of things that I want you to remember. If you have more than 1 mole, of mass, the mass is going to be greater than the gram formula mass. So if you have more than 1 mole of a substance, the mass that you calculate should be greater than the gram formula mass. If you have less than 1 mole of a substance, then the mass is going to be smaller than the gram formula mass that you calculate. What does that mean? Let's check. So, for our first example, we have what mass of 4.5 moles of KOH. So what mass is equivalent to 4.5 moles? So we need to total up our molar mass. So we're going to do that first. We have 56.1. Then we're going to plug into our gram formula. Our mole calculation formula says that we have 4.5 moles is equal to X. We don't know what mass that is over the gram formula mass. So what we're going to do is we're going to place 4.5 moles over 1. And then what we're going to do is we are going to cancel moles. We have moles in the top, moles in the bottom. Then we're going to crisscross. So we're going to get 1 times X. It's going to be equal to 4.5 times 56.1. When you do that and solve, you get 252.5 grams. We have more than 1 mole of KOH, so our mass calculated should be larger than the mass of 56.1. It is, but here's where sig figs are going to come in. This answer has, this number, 4.5, has 2 significant figures. The answer that we've calculated has 4, so I'm going to round that to 2, which would be 250 grams. And that is your final answer. And notice how I have a box around it. That's what I want to start seeing on yours. All right, let's look at example 2. Example 2 is what is the mass of 0.5 moles of copper 2 sulfate. So we're going to have to total up our mass, and we get 159.7 grams per mole. Then the next thing we're going to do is we're going to set it into our formula. 0.5 moles is going to be equal to some mass, X, over 159.7 grams per mole. So now what we're going to do is we're going to put 0.50 moles over 1. Moles are going to cancel. We have moles in the top, moles in the bottom. Now we're going to crisscross multiply. And when we do that, we get an answer of 79.85 grams. Okay, again, this answer only has 1 sig fig in it, or 2 sig figs, excuse me. The 5 and the 0 are significant, so we're going to have to round our answer to 80 grams. Here's the first practice. I want you to try this on your own. So you're going to pause the video, follow the exact same models that I just did in example 1 and example 2, and see if you can come up with the right answer. Great, well, welcome back. Calculate the mass of 6.7 moles of carbon. You should have just been able to go to the carbon on your periodic table and gotten your mass. Then what you're going to do is you're going to hit 6.70 moles is going to be equal to X over 12.01 grams per mole. We're going to stick 6.7 moles over 1. Then we are going to cancel our moles, which is what we want. So we're left with grams, which is the unit we want. Then what we are going to do is we're going to crisscross and multiply. And when you do that, you get 80.4. And that is the final answer because it has 3 sig figs, and our original moles of carbon had 3 sig figs. Let's look at practice 2. Again, try this on your own and unpause when you are finished. Great, well, welcome back. Calculate the mass of 22.35 moles of MgSO4. So we got to first total up and get the mass of MgSO4, and it's 120.3 grams per mole. We plug it into our equation, so we have 22.35 moles is equal to X over 120.3. Set 22.35 over 1. Moles are going to cancel. Crisscross multiply, and your answer will be 2,688 grams. And that will be the final answer because that has 4 sig figs, and the original mole number that you started with also had 4 sig figs. So now here's your second check your understanding. I want you to try this, and we'll go over this first thing tomorrow in class.